Now that we know how to create histograms, we want to look more at using them to interpret data. So to do this, we're going to look at the properties of histogram, and some of the important properties are the shape and different patterns. So let's look at that. First, the shape. The shape of a histogram can be described by looking at its peaks. So if we look at this histogram that we saw from the last section, we can see that it's got a high peak here on the left, and then it kind of trails off to the right. Alright, so that's the shape of that histogram, and there are some words that we can use to describe shape. A right-skewed distribution is a distribution in which the longer tail of the histogram is on the right side. So that's like the example we just looked at. A left-skewed distribution is a distribution in which the longer tail of the histogram is on the left side, so that's the opposite. And finally, a distribution is symmetric if you can draw a vertical line on the histogram with the left and right sides looking like mirror images of each other. So let me draw just an example of what that would be like. So if I have a histogram that's got high values on the left and then trails off to the right, that is right skewed. A left skewed histogram is the opposite. It's gonna be low on the left and then come up to a peak on the right. And finally, a symmetric distribution can look something like this. So I've got a peak in the center, and if I draw a line down the middle here, I've got mirror images on either side of my dotted line. Let's look at another example. This histogram shows test scores for 7th graders. And this is their vocabulary score. And what's the shape of this histogram? Well, if I look at it, it's got the shape, it's got one peak in the middle, like this. So that looks pretty symmetric. I can draw a dotted line here at around 7, and I've got a mirror image on either side of my dotted line. So that's symmetric. What are some other features besides shape that we can look at? Well, the center of a distribution is the value for which half of the individuals fall to the left and half of the individuals fall to the right. So that's one feature, and we saw that in the last example. The center was around 7. The span of data from lowest value to highest value is called the variability of a distribution. And finally, an outlier is an individual value that falls outside the overall pattern of the distribution. So let's look again at this histogram with the percent of Hispanic population of states. What's the center of this distribution? Well, I've got most of my states concentrated here in the first couple of intervals. So if I had to guess, I would say my center is probably somewhere in this second interval, just looking at it. And it turns out that the center of the distribution is 6.8%. So if I look at all of the states, half of them have a Hispanic population of 6.8% or less, and half of them have a population of more than 6.8%. So that's about here on my graph, and that's about where I thought it would be. What about variability? Well, remember that we said the state with the lowest percent of Hispanic population was Maine with 1.0%, and the state with the highest percent was New Mexico with 42.3%. So the variability is from 1.0% to 42.3%. From the lowest value to the highest value. What about outliers? Well, we said that New Mexico might be an outlier, and it turns out that New Mexico, it differs from its nearest neighbor, which is Texas, by 8.7%. So it's pretty high compared to all of the other values. So that might be an outlier. Finally, let's go through one more example. So this chart shows tuition and fees charged by the 55 four-year colleges in the state of Massachusetts for the 2007-2008 academic year. And we're going to make a histogram for this chart and look at the properties. So first I'm going to make a grouped frequency distribution. And to do that, I'm going to divide up the range of values into intervals of 4,000. So my first interval is going to be from 2,000 to just less than 6,000. And that will include my lowest value. I've got my values nicely arranged in order here. So my lowest value is 5,799 on the low end. And then my highest value is 36,700 on the high end. So if I break that up into $4,000 intervals, I'll get these 9 different classes. So let's go ahead and fill in this chart. And that should be easy since I've got everything arranged in order. For the first class, I'm going to count all of the schools that have tuition up to $5,999, and that cutoff point is right there. So I've got 3 schools that fall into that interval. My next interval is up to 9,999, so that's going to cut off just after this school here, and there are 8 schools in that interval. My next interval is from 10,000 to 13,999, and turns out that I don't have any schools falling into that interval because my next highest school is at $16,080. So I've got a count of 0 for that interval. My next interval goes from 14,000 to just under 18,000, so that will include these 2 schools there. And then I'm looking for everything up to just under 22,000, so that will be those 3 schools there. Then everything up to just under 26,000, that's going to bring me all the way here on my chart, and there are 13 schools there. Then everything to just under $30,000 will bring me up to here on my chart, and there are 7 schools in that interval. Now everything up to just under 34,000, I've only got a few schools in that interval, so that's going to be 3 schools. And then all of the other schools are going to fall into my last interval, and there are 16 of them. So that makes my grouped frequency distribution, and I just copied it over on this next slide here. And let's use that to draw our histogram. So I've got number of colleges on as my vertical axis here, and I've got that ranging from 0, which is my low value, and my high value is 16, so my axis goes all the way up to 16 here. And then across the bottom I've got my tuition and fees in thousands of dollars, and these are a little bit off here, so this starts at 2 and goes up in $4,000 intervals. Alright, so let's go ahead and fill this in. So my first interval, I've got 3 schools, so I'll draw a bar of height 3. My second interval has 8 schools. My third interval has 0 schools, so I've just got a flat line here and no bar. My next interval has 2 schools, and then 3 schools, Next one goes all the way up to 13, which is about there. So there's that bar. And then back down to 7 here. And then 3. And finally my last interval goes all the way up to 16 for my highest bar. So that's my histogram. And here I've copied it. It looks a little bit nicer. So let's look at the properties now that we've drawn this histogram. What about the shape? Can we say anything about the shape? Well, it doesn't look like, it's not really skewed in one direction or the other. It's got a bunch of peaks here. I've got a short peak here and then a couple of higher peaks. So I'd call this an irregular distribution. It's not skewed in either direction and it's also not symmetric, so I'd call it irregular. What else can I see here? Well, I've got a gap here and I've got some colleges on the low end, and then I've got a group of colleges on the high end. So there are two separate clusters of colleges, and that actually divides up the colleges. These ones with the lower tuition are the state schools, and these with the higher tuition are the private schools. So that finishes up that example, and here's just a list of things you should know from this section. You should be able to describe the shape of a histogram, tell if it's right skewed, left skewed, or symmetric, or if it's none of these, then we'd call it irregular. You should be able to identify the center of a distribution, which is the point where half of the individuals fall below that point and half of them are above that point. You should be able to find the variability of a distribution, and this is just the range from the lowest value up to the highest value. And then identify possible outliers in a distribution, so individuals who fall outside of the general pattern of the distribution.